VMware User Group, or VMUG, is an independent, global, customer-led organization created to maximize members' use of VMware and partner solutions through knowledge, sharing, training, collaboration, and events. Get connected to a local VMUG community near you at myvmug.com. We have them all over the United States, all over Europe, and frankly, all across the globe. So if you're looking for other VMware users around you, go to myvmug.com and get connected. During this webinar, please use the Q&A function for all your questions. For Nathan today, we also have another panelist who will be joining at the end. But the Q&A function just allows us to track your questions better, as questions that are put into the normal chat might get lost. And if additional follow-up is needed, we'll be able to take down your email via the Q&A function. And lastly, this session is being recorded. The recording will be distributed in a wrap-up email after the webinar, and it will be uploaded to the VMware User Group YouTube channel. And without further ado, I'll turn things over to Nathan.
All right, thanks so much, Tristan. Let me get my screen share going out here, and I will get rolling into this. Okay, good to go on the screen. Can you guys see it? I'm assuming yes. It looks like the share is going. All right, I'm going to go ahead and press if I don't hear anything else. Hey, everybody. Thank you so much to Tristan for the introduction. And yeah, my name is Nathan. I work at Vali Cyber doing threat intelligence work along with a little bit of solutions engineering. And today, the primary reason that I'm here to talk with you all is about VCF and how VCF can be extended to be even more useful for protecting virtualized environments that are running hypervisors like ESXi. And so without, too much preamble here, I'm just going to go ahead and launch into it and talk about some of the changes that have been brought about in VCF and how it's sort of shifted the ideas that a lot of folks have about securing their virtual infrastructure. You'll see that there's a quote up here on this slide. We run VCF, so our hypervisor is covered. And although VCF does provide some really good coverage for hypervisors, it does do some really interesting things and some very, very useful things that I would never want to tell people not to use. It doesn't really protect the hypervisor itself directly in a lot of ways that are pretty important. So the products that I'm going to focus on as we kind of talk through this are vDefend ATP, the advanced cyber compliance capability, and also live patching. And you'll notice that exec installed only is kind of listed under there under advanced cyber compliance too. But we'll touch on that a little bit. And we'll talk a little bit about how this does do a lot to help protect the hypervisor from the outside. But there's a lot of things happening at the runtime level inside of your ESX environments that are still going relatively unprotected. So to put a little bit more color on each one of these capabilities, let's talk about what they do. So advanced cyber compliance is really configuration drift and a lot of configuration tracking and compliance help. It's really useful for understanding when things do change, when you do have that drift, and helping you maintain a good stance and being compliant through most scenarios. vDefend ATP is a really interesting tool as well. This is where we get, if you've ever heard anyone talk about it and talk about some of the new security capabilities within VCF or vDefend in general, you probably heard them talk about microsegmentation and doing things like ensuring that your network is microsegmented so only the correct things can talk to each other and how much that buys down risk by reducing things like attack surfaces. And that's all very, very true. It's great, but it is all network focused. If you've heard us talk before, you've heard us talk about network protections, and network protections are great. They're part of a complete security ecosystem, but they don't solve every problem, particularly when it comes to, well, either savvy attackers who are willing to do the technical work to circumnavigate them, or folks who gain authorized credentials. So when we look at things like social engineering, which are all too common, a lot of times this gives them an undue amount of access to things like network protections and makes them not as effective as they would be in other scenarios. Then we can talk a little bit about live patching. So live patching is great as well. Really what this is doing is it's reducing the amount of time required and the number of resources required to apply patches when they are available. And I really want to hit on that part, the when they are available part. That's going to come up a little bit later as we talk about some of the vulnerabilities that have come out for ESX and how long there has been a gap between the exploit being known and a patch existing. Live patching is wonderful, and I definitely recommend that folks use it where applicable, because it does reduce the need for things like interruptions to service just to apply patches. So again, definitely a step in the right direction, a really, really good thing, and it can help address some of the vulnerabilities at the hypervisor layer, but it doesn't do a lot for anything dealing with runtime. It doesn't do anything for, authenticated social engineering attacks and the like. So we'll get a little bit more into that, but first, just to give you all a sense of where VCF and the vDefend toolset is kind of coming from and what it does do well. And we're going to talk a little bit more now about why it's not solving every problem. So the real big issue is that hypervisor security has become an increasingly large problem over the last couple of years. And again, if you've heard us talk before, myself or anyone else here at Vali Cyber, you know that this is something that we've been talking about for the last couple of years. Attackers are starting to take notice of virtualized environments. They're starting to take notice of the hypervisor layer in particular. And to give you a couple of concrete examples, we could talk about Scattered Spider. They were really big last year. Lots of attacks, lots of really big name brand, quote unquote, attacks that Scattered Spider perpetrated. And although they've reduced their frequency a little bit this year, and there have been some arrests made within that group, others are following suit. So you can see on here, we also have listed people like Shiny Hunters along with their, Shiny Spider ransomware. There are a few others. There was a big attack from Anubis the other day that targeted not ESX but Nutanix hypervisors. So the hypervisor is increasingly still, well, it's still a target. It's not something that really appears to be going away. And for most organizations, a big part of the reason for this is because it's a lot of impact. And it's really hard to monitor and protect because most security tooling has not focused on it for a long time. I'll also call out that kind of last bullet there. There's no malware signature to catch with a lot of these, the scattered spider techniques that people are emulating now because they're using native tools. They're doing things like living off the land attacks where they're just using the things that already exist on ESXi, like OpenSSL or Netcat or other tools that exist natively within the host itself. So you can see a little bit of a breakdown of how this technique works. And this is a pretty simple one over there on the right-hand side under the technique. They steal keys of some kind, whether that's an SSO token or an SSH credential. And if needed, sometimes they've already gained access to the network through like a 0-day on a VPN device or straight up just through social engineering, right? So one of the traditional examples we talk about a lot is doing a SIM swap and then impersonating someone, calling the help desk, getting a password reset, and then gaining access to an organization's network that way. So once they do that, they can run a loader for their attacks within ESX's built-in shell. There is a shell on ESX, even though oftentimes by default it is disabled, as is SSH. When someone already has access to the network, this often becomes a moot issue. It's really not something that stands in a lot of attackers' way. Oftentimes, what they can do is they can just simply enable it with the privileges that they already have through their SSO token or through other connections or coming in through that network-based 0-day or something like that. Then they'll use native tools. You can kind of see this listed there: OpenSSL, Python, SH. These are some common, very, very, very powerful examples, and all of them exist natively on ESX as well as every other hypervisor that I can think of. Don't quote me on that. I don't want to say all of them unilaterally definitely do have this, but the vast majority certainly do, as do most Linux hosts. From there, it's all about the techniques kind of vary from this point, where it's either snapshots disabled, data stores mounted, deleting other backups if they can find them. Lots of things going on there, depending on the exact architecture of the organization that they're targeting. But essentially, the idea here is that they want to disable the ability to remediate the attack. So they want to try and remove backups, disable those snapshots, do whatever they can to make it hard for you to get your virtual machines back and to restore access to your hypervisor. And then the final step is oftentimes just encrypting those VMDKs in the instance of ESX at least. But in all instances, it's encrypting the virtual disks associated with the guest operating systems, the guest machines that are running on top of it. So it's a common technique. There's lots of different variations of this in terms of specific tools that get used or the exact service that's exploited. But most of the attacks that we've seen against hypervisors, particularly when it comes to ransomware, focus on some variation of this basic attack chain. Yeah, and another thing to talk about, well, and I'll highlight this really quick too. with the previous example, very little in the way of exploits for ESXi is required. I mentioned maybe a VPN or a network device 0 day, and those are fairly common. We see a number of those every year for the last few years at least, but not necessarily exactly what's needed. Most of the attack chain that I talked to you about before doesn't even really require an exploit, right? Assuming someone can gain access to the network from social engineering or maybe even from physical access or from misconfiguration. There's a lot of ways to do all the things that we talked about just a moment ago without any kind of vulnerability. But what I'm about to talk about makes the problem even worse. So this is where we get into things like real software level exploits that exist against ESX. So the one that you see on the screen of that first bullet here is the May 16th, 2026. And actually, I've made a very quick edit to this because things are moving very, very fastly or very, very fast with this. There was a live exploit that was demonstrated at Pwn2Own Berlin in May of this year. Now, this may sound like deja vu or maybe causing deja vu in some of you who are listening because this also happened last year. This happened in 2025 as well. And the pattern between these two, I think, is worth paying attention to. So this was a full memory corruption flaw that allowed for VM escape as well as cross-tenant code execution. So a pretty nasty exploit. Now, luckily, it was disclosed at Pwn2Own, which typically the technical details are not disclosed to the public. They're simply disclosed to the vendor, and then there's a cash reward for the researcher who demonstrates it, which is exactly what happened here. But unfortunately, as it is with all things, when someone knows that it's possible, it's a lot more likely that they're going to figure out how to do it, even if you don't explain it to them. And we've seen this happen time and time again. It happened last year where when this vulnerability was disclosed, there was some public POC code that came from a different organization, a different researcher that looked very, very similar to what was being described at the Pwn2Own competition. Last year, it took just about 60 days. It was on July 15th of 2025 when they were able to finally release the CVE that was associated with the virtual machine escape, as well as a patch from Broadcom. So in the interim, there was 2 months where we knew that an exploit existed. We knew that there was a vulnerability, but there was no patch available. So even if you had the resources, you had the time, and you could update your ESX hosts, it wasn't possible to update your ESX host because no patch had yet been made available. Now this year, uh, what we've seen is that it took a little bit longer than 60 days. In fact, it was yesterday. So we had May 16th of 2026 is when this vulnerability was disclosed. And then it was all the way through. Oh, sorry, actually, that's under 60 days because we're in July. My apologies. I did this in a rush this morning when I was trying to update the exact timeline of this. But they were able to just beat it by about 2 weeks. So we still had about a 45-day gap. Or wait, is my math wrong? This is the problem with doing public math, you guys. May to June to July. No, we are over 60 days. So we've had an over 60-day gap between this. If you want to see more information about exactly what has now been done by Broadcom VMware, you can go check out VMSA 2026-0006. It includes there was multiple CVEs that were listed here, and I didn't have quite enough room for them on this slide, but you can take a look there, and it'll link you to all of it as well as giving you details about which versions need to be patched. But really, the point of what I want to talk about here is to show you that this is a recurring problem. This is not something that's gone away. This is a fully fledged virtual machine escape attack that is pretty nasty. For all those of you who are familiar with a lot of the threats that exist against hypervisors, having a virtual machine escape is pretty bad. This is a gnarly one to have, and it's a hard one. It's a hard one to kind of shrug off, which is why this is one that we like to talk about a little bit and discuss kind of the implications of a lot of this, as well as some of the hard situation, at no fault to Broadcom VMware. It takes time to solve some of these issues. And unfortunately, while that time is being taken, it is vulnerable to attackers. And so that's something that we think is a problem that can be solved in other ways outside of just patching. And we'll get into that a little bit here in a minute and how we have to kind of go beyond VCF to be able to address some of these in a more timely fashion. So how do we fit into this? Why am I talking about this? Where does ZeroLock, which is the security solution that we here at Vali Cyber have, how does it fit in with VCF and help to solve some of the problems that we're talking about? Now, if you look at this, kind of brief table, you can get a sense for what's going on. Essentially, what we've noticed is that VCF provides a lot of really good perimeter-based, network-based, and patch-based protections. So it can do a good job of helping you understand if you're in compliance. It can help you at the network level with doing things like inspection of traffic and with microsegmentation and the like. That's all very, very good. And it's an area that really ZeroLock doesn't focus on as much. It focuses on network connections from the host level, but not at the network level. That's not an area where we're really playing. And when it comes to patching, the way that we handle this is we don't necessarily require a patch to be able to address some of these vulnerabilities. And when we talk about the virtual patching capability within ZeroLock, I'll get into that a little bit more. But it's really just to highlight for you all that these two things exist at different layers. VCF exists kind of more outside the core level of the operating system, or maybe within the ESX operating system when a patch is available, where ZeroLock is resident on the hypervisor, and it cares about things that have already made it through the network layer. It cares about things like those social engineering attacks where someone has access despite all of the protections. ZeroLock just exists at a little bit of a lower level than a lot of the protections that exist within VCF. And to really kind of dig into this, I like this diagram. I think this actually does a pretty good job of describing what we're talking about here. You can see where VCF really plays in. We know that it exists to help protect some of the workloads when it comes to the network protection provided by vDefend ATP and the advanced cyber compliance that helps us understand if we are in fact having configuration drift. Those all work around those virtualized workloads to help to protect them, right? And it does so in a pretty decent job. And then down at the hypervisor layer, the two things that it can address are that live patching when a patch is available. But we've already kind of talked about how you should be patching when a patch is available, but sometimes there's a pretty long gap between when a problem becomes relevant and when a patch is actually available. So there's that. And then exec installed only, which I haven't talked about quite as much here, but exec installed only is a great capability that helps prevent unknown binaries from being run on ZeroLock. It requires things like a VIB. Now, that's really, really good. It does help with things like different malware that might get brought in, but unfortunately, particularly savvy attackers have found some ways around the native exec installed only capabilities, including things like calling things through interpreters, which circumnavigates it, and or using malicious VIBs, right? So it's a great protection, and it does help reduce a lot of the low-hanging fruit of someone just moving a binary and trying to execute it. But for a particularly motivated attacker who's done a little bit of research, it's not too hard to understand how to circumnavigate things like that. So again, these are all great protections, and I hope that they're all enabled in every ESX environment. But unfortunately, they still leave us vulnerable to some types of attacks. Now to dive in a little bit more into what ZeroLock is really doing. So this is what we kind of affectionately refer to sometimes as our layered defense onion. And I'm going to work through it a little bit to talk about how we differ and why we're really focused on preemptive runtime security, right? We're focused on trying to address things behaviorally before they become a real problem. Um, you can see we've got this perform, preempt, protect kind of keywords that we like to talk through, and I'll touch on those a little bit here. But what I really want to do is I want to break down the different layers within that onion that you see there on the screen and talk about how they help to address some of these issues. So CLI MFA, we can use this in a lot of different ways. This is really when you have kind of a gray area. So you have a command that maybe is a legitimate administrator tool. Think on ESX, things like ESX CLI, VSISH, those sorts of things. You may need them for administrative tasks occasionally on ESXi, but they shouldn't be run a lot of the time. What CLI MFA does is it imposes a multi-factor authentication on any command line utility. So you can have it be, your ESX CLI commands. If someone tries to run ESX CLI, software install, they're trying to run a new VIB or something like that. What ZeroLock will do, it will hook that command before it's allowed to execute. It will say, hey, provide me multi-factor authentication. Let me confirm that you actually have the ability to do this. And not only is it having you provide that authentication, but it's also keeping a log of when that gets done as well, which can be really, really good for, down the line audits and kind of change controls and the like. So adds an extra layer of defense on things that have typically been completely defenseless. Typically, it's been you gain a shell on ESXi, you gain access to the administrative capabilities, and it's game over. Then the attacker can essentially just do whatever they would like to. But with CLI MFA, that becomes a little bit less the case. The next layer down is that application allow listing capability. Oh, excuse me. You got to sneeze? Okay. My apologies. The application allow listing, this is another really good capability that kind of mirrors the exec installed only function that we saw within VCF. The difference here is that it goes a couple layers deeper. So things like calling programs through interpreters won't circumnavigate application allow listing. And and other than that, really what it's doing is it's trying to address a similar problem where we're saying, hey, someone is bringing in a foreign binary into this hypervisor. We want to prevent its execution, right? We want to preempt it. So this is really what starts to fit into that preempt keyword that you see over there on the left-hand side of the slide here. Lockdown rules are when we can't block the thing entirely, but we want to constrain its behavior. So for this, think things like host D or the VMX process that handles a lot of the virtualization on ESXi. They're necessary. We have to have those in order for the hypervisor to be a hypervisor and do what it needs to do. But unfortunately, if they do have software vulnerabilities, they can be used to do malicious things occasionally. In the case of many of the virtual machine escape vulnerabilities that we talked about, and the reason I talk about these so much is simply because they're public, right? They're public and they're very widely publicized through the Pwn to Own competition. So they're a really good way to talk about some of this stuff. But when those vulnerabilities get exploited, what they do is they take advantage of the VMX process. The VMX process will go and it will do something that it should not be doing, like spawning a shell or making an outbound network connection, that kind of thing. What we can do with a lockdown rule is we can constrain that behavior explicitly. So we can allow VMX to continue to run, to do its thing, to run the virtual machines on the host as needed. But as soon as ZeroLock observes that it's done something that we have a lockdown rule for, like spawning a shell, an outbound network connection, then it can trigger protection. It can both detect that behavior and take action against it if needed and if that's what we've configured it to do, right? So this is really why we talk about lockdown rules leading into things like virtual patching as well, is because although we're not Broadcom, we can't create a real patch for the code because we don't own the code, it's theirs. What we can do is we can prevent that vulnerability from being exploited. So we can virtually patch it and mitigate a lot of the issues that exist because of those software vulnerabilities. And then eventually, 2 months later, when a patch does become available, you can of course apply the patch when you have the time and resources to do so, knowing comfortably that you have a virtual patch through ZeroLock that is mitigating the exploits associated with those vulnerabilities. Our last layer in is that AI detection and the automated remediation. This is really a last line of defense, right? So this is a capability that looks for a couple of very, very specific behaviors, things like ransomware, cryptojackers, tampering with the operating system fundamentals, those sorts of things. And it's able to detect them agnostic of any file that gets used, any binary that gets used, agnostic of whatever process it is. It can be a known good, trusted process on the host, and ZeroLock will still detect it if it exhibits the behaviors associated with those types of attacks. This is not something like a ChatGPT wrapper or a Claude wrapper. It's not a big LLM. It's not reaching out to the cloud. I should note that all of this can run air-gapped and requires no cloud connectivity. It all runs on the agent. We're able to do that because these have all been custom built from the ground up by us. We're using our expertise in Linux and in hypervisors to kind of to be able to get at a lot of these issues. Because they're custom built, we don't have all of the overhead of other machine learning models. These are very, very, very small, very, very custom built ones specifically for detecting these types of behaviors on Linux and hypervisors. So this is just kind of a brief overview of what ZeroLock is really doing. And when it comes to the perform, preempt, and protect, the preemptive capability is really where we talk about stopping the attacks before they become a problem, right? With CLI MFA, application allow listing, and even lockdown rules to some degree. The protection comes in with AI detection and automated remediation and being able to do things like automated file rollback. This means that even if a couple files did get encrypted somehow, ZeroLock is then able to put them back into a pristine state before the attack happened. And when we talk about perform, I haven't hit so much on this. We'll talk about this a little bit more here in a second, but it's very, very lightweight and flexible. In addition, as I mentioned a moment ago, it's deployable in a really wide number of environments. We don't have cloud dependence, right? No network connectivity dependence. You can set it, and then all of the protections will function without any connectivity to the outside world. Something else kind of to highlight is that the MITRE attack framework does have an ESXi matrix now. There's a whole set of TTPs associated with ESXi that MITRE has produced an attack framework for, and when configured correctly, ZeroLock can address 100% of them. I think that's something that we're pretty proud of, and that I think is a noteworthy thing. We're really the only ones doing this preemptive security and hypervisors right now, despite the need. I think folks are just struggling to kind of catch up at this point. But we're really proud of the fact that when we've looked at those third-party tools like MITRE ATT&CK, we are able to address 100% of the things that they are concerned with. Okay, so I'm going to talk a little bit about the performance now. We're going to get into some of those keywords, the perform, preempt, protect kind of business here. So I'm going to touch on each of these, our approval from Broadcom, the resource utilization, the deployment and management and everything. And then we'll get into some of the fun stuff here. So approved by Broadcom. We do have a signed VIB from Broadcom that means that we can deploy without reducing, protective levels on your ESXi host. It's all deployable through vCenter using the Lifecycle Manager, and we are a VMware Technology Alliance partner. You can see some very, very kind words that have been made by some of the folks over there at Broadcom about what they've seen when it comes to our when it comes to our software, right? When it comes to ZeroLock and what ZeroLock is able to do. We've been happy to be able to get a lot of reviews like that from folks that we work with. This is a very, very performant technology that's able to do a lot without too many resources. And to kind of touch on that a little bit more, I'll mention very briefly that typically what we take is about 50 megabytes of RAM on the host that's running one of our agents. And that is our typical architectural model. We will have a server that can run as a virtual machine in your environment. Typically, we'll pass it to customers as an OVA to just make it super, super simple to deploy in your environment. And then it runs as a bunch of containers on top of that that provide a web console that you can reach out to. All of this is API first and we can send all of the data to another third-party SIM. So if you have your favorite SIM or SOAR that you're using that you don't want to have another screen that you got to go check, that's no problem. All of ZeroLock's data can be exported to another, third-party SIM or SOAR, and we're happy to work with folks on things like that. But from that ZeroLock management console, from the server itself, we take our agents and we deploy them on the hosts that we're trying to protect, right? And so you can see a selection of ones down there. Obviously here for this audience, we're focusing on VMware ESXi, but we also have protections for things like Proxmox, Nutanix, Citrix, Red Hat's hypervisor solution, as well as any KVM-based hypervisor that, just runs a Linux operating system. We have really good configurations out of the box as well for most of those environments, especially the ones that we've done lots of work and deployments with customers in the past, like ESXi. This allows for pretty flexible deployment and really, really, truly low overhead. On ESX hosts, the number we talk about for compute is typically about 5% of one CPU core, in addition to that 50 megs of RAM that you see there for memory. And that's under pretty nominal circumstances, right? When ZeroLock is just going through and doing detection and monitoring. That's about the resource usage that you can expect. Yeah, very, very flexible. We can lift and shift with no headaches, as you see there on the bottom of the slide. That's something we like to say. Yeah, very, very flexible capability and very scalable as well. Because everything is running on the protected endpoints themselves, there's not a lot of overhead that gets incurred by the server because it's all distributed to those hosts at the actual runtime level. So now I get into a little bit of the fun part though, and I promise I thank you guys for hanging with me through a lot of the slides. Now we actually get to see some of the fun stuff. So I'm going to demonstrate for you now a couple of these protections and how they really play in with different attack vectors. So to get started, let's jump into the CLI MFA capability. The first thing I'm going to do though is give you a little bit of a tour of this environment. So you can see we've got, I think this one's got just over 400 protected endpoints. We're going to focus in on those ESXi machines that I was just circling. And just to pause here really quick, we've also got, this is one of those protected ESX hosts that we just saw being monitored by ZeroLock. This is just the web UI for that ESX host. We've got 3 virtual machines within it: Gandalf, Frodo, and Gimli. And we're going to be targeting this particular environment a couple of times today, so I just like to highlight that first before I let it go too far. Now, I mentioned that the first thing we're going to check on is that CLI MFA capability. We're going to do it using SSH this time. So we're going to attempt an SSH session with an actual legitimate password, and we've actually already passed that part. So attempting to log into that ESX host with SSH enabled, it asked us for a password. Many of you are probably very familiar with this process. It asked us for a password, and we did provide the legitimate password for this host, even though we're trying to, gain access maybe in a nefarious way as an attacker. It was letting us in because we provided that until ZeroLock saw what was happening, and it asked us for multi-factor authentication. So we tell it who we are, and then we go into something like Google Authenticator or Microsoft Authenticator or whatever other time-based token generator you're using, and we put in our time-based token, and only then are we actually given access to this host using SSH, and then it gives us a shell. Now, I mentioned previously, this capability is usable across the board for all CLI capabilities. So it doesn't just have to be SSH, it can be ESX CLI, it can be NC, it can be LS, it can be whatever you'd like. That one maybe don't do. That would probably be a little bit of a nuisance to put it on LS since that's a pretty innocuous command. But if that's what the constraints of your environment require, absolutely it is something that ZeroLock is capable of doing. This is a really, really powerful capability. And it's one that we think can be put to really good use to secure hypervisors in a lot of environments, simply because it provides that extra step. It slows down an attack at the very, very least. And in many instances, it completely thwarts most attacks if the attacker does not also have access to your time-based token generator. All right, application allow listing. This is another fun one. Now, before I actually hit play on this particular demo, I want to just highlight what we're looking at. So you'll see here this little one-line script that I've got loaded here. We're running a wget command to download the Brickstorm malware from somewhere in this environment where I'm hosting it. Brickstorm is a legitimate malware campaign used by predominantly Chinese threat actors. So this is it's a Chinese, state-aligned capability that provides long-term persistence on vCenter and ESXi. So this one that we're looking at right here actually is a real Brickstorm sample that we use in-house. It's one that part of my team, the threat intelligence team, we've gone out and we've hunted out some of these malware samples that are applicable to the host that we protect. And now we're able to do testing on it in-house and ensure that ZeroLock can provide the best protection possible. So let's see what happens as we try and download and run this Brickstorm malware sample. So we're going to try and download it, and then it's going to go through chmod plus X to make it executable, and then we're going to attempt to actually run it. What you'll notice is because we have it configured to allow for wgets, the wget was successful, right? So we were able to download, but then our connection got closed. And let's kind of see what happens as we dig into this a little bit. That's what we see from the attacker's perspective. And if we come over here to the alert, we can see that there's a suspicious executable alert. And the first thing that you notice is that when we dive into the alert, ZeroLock has a lot of really good forensic data. Lots of really, really good data that gets reported back here. And when I say forensic data, I don't necessarily mean, hard drive forensics, but instead just breaking down the attack as to what happened here. What were the files that were associated with this attack? What are the processes that were associated with this attack, which you see here presented in this graphical tree format. And you can see everything through. I always like to highlight this. You can see going all the way back to PID1, so all the way back to the initial process on this ESXi host, through the SSH daemon here, through the BusyBox shell that we were actually using after we authenticated, and then you can see the Brickstorm execution over here. So ZeroLock gives you really, really deep view of everything that happened over the course of this attack, including the things that weren't inherently malicious themselves, right? Whenever it notices something that is malicious, it also reports the things around it that happened. Just so that we get a good sense of everything that the attacker really did over the course of the incident. Okay, now if we're to jump into anti-tampering, this is kind of a fun one too, and I'm going to let this one play here for just a second, and we'll kind of talk about what we're really preventing here. Now you've seen me through the course of these videos. I'm going to hit pause here really quick so I can talk about what we're about to watch. You've seen me try a couple of different ways to get after this ESXi host. Now, if I'm a bad guy, and I'm trying to either, deploy a ransomware attack or maybe steal a bunch of data from this ESX host. I've already exhausted a couple of the major ways that I might be interested in doing this, right? I've tried to gain access over SSH, and without an MFA token, that's not going to be a possibility. I've tried to deploy, that Brickstorm sample to give myself long-term persistence, and I've gotten thwarted a couple of times. And what I've noticed at this point in this scenario is that, hey, maybe there's a security solution. Maybe it's ZeroLock, right? Maybe we're giving my attacker persona a lot of advantages here, and assuming that maybe they started to notice that ZeroLock is causing problems. So what you'll see here is a lockdown rule. And we don't have enough time today really to dive into the ins and outs of exactly how lockdown rules are structured, because we could probably spend a couple of hours talking about just that. But this is one of them that you can see the title is that it's an ESXi rule and it's ZeroLock service manipulation through host D. Now, there's a lot of other ways that we can get after this problem, but this is a pretty powerful one. And what we're going to do is we're going to be looking at this lockdown rule in particular. Now, it's a program execution lockdown rule, which simply means that it's looking for maybe the execution of a command or a specific binary, something like that. And it's coming through the host D process. Host D on ESX is the process that handles a lot of the things like web requests. So if you log in through vCenter or through the ESXi web UI, most of the requests that you make and the actions that you take are going to be coming through host D. This is also applies to API calls. So if you're using things like Power CLI and the like, which we're going to be doing that here in just a minute, which is part of the reason that I bring it up. If you're doing something like that, then hostd is really the process where a lot of that behavior is going to be coming from. And what you can see here, I'll let the video roll through because I'm going to highlight this here in a second, is that hostd is listed as our source process. And then you can see there's a regular expression down here for the target command that uses ZeroLock and then different variations of stop, restart, remove, off, and then different placement of a lot of those different types of commands there in that regular expression. So what it's looking for is it's looking for a command that matches the second regular expression there coming from host D. And what I'm going to be able to show you now is if we come back over here, I've got this remove component PowerShell script. I've installed PowerShell on this Linux host that I'm working from. And if you take a quick look at the remove component script that I'm about to run, I highlight it here just so you can get a sense for what's going on. The first thing I'm doing is I'm logging in using valid credentials. I have a real API key because we've already established that I have administrator credentials in this environment. So I have a real API key. I'm going to go ahead and I'm going to do my login. And then once I do, I am going to try and run this command down here. Then it's including this arguments. And in arguments, we can see things like the component being ZeroLock. So we see ZeroLock is provided as an argument, as well as saying that it's not a dry run, and that this is a removal request, right? So we're making a command to ESXi to remove ZeroLock as a component. So the reason I'm trying to do this as an attacker, right, is because I want to be able to continue with my attack. And the first thing that I need to do, be able to do that is stop whatever it is that's been stopping me. Something has been preventing me from taking action. And unfortunately, what you can see here is that I got an error code back when I attempted to do that. And if we come over here, we'll see that we have a program execution alert, and it matches that lockdown rule that we were looking at earlier, that ESXi ZeroLock service manipulation through host D. So ZeroLock was able to observe this. Part of the reason I like to show you all this is to show you the power of some of the behavioral triggers that we can put in here. So saying, host D should do what host D needs to do, but we shouldn't allow it to do a certain subset of things like removing ZeroLock or otherwise tampering with the operating system. Let's take a look at how ZeroLock reports this. So no files were modified. That was important, right? We saw that screen was blank, but over here we can see the host D process, and then we can see that it's spawning another command here. And if we open it up, we'll even see that this is a full ESXi software component remove ZeroLock, exactly how we formatted it over there in our Power CLI script. So it was able to observe every stage of this. We know that it came through hostd, so it came through an actual hostd authenticated session. But despite all of that, despite being a valid API call with real credentials, ZeroLock was able to identify the specific behavior that we defined, and it was able to take action against it and prevent this ESXi host from being tampered with. So this is a pretty powerful capability, I would say, overall. And it's that's one of over 200 lockdown rules that come out of the box in ZeroLock. So I've just shown you one of them. Not every lockdown rule is applicable to every different type of system, right? Some of those maybe are Nutanix specific, some of those are ESX specific, some of them maybe are Linux server specific, but still all of them can be leveraged, copied, tweaked, modified to suit the exact needs of the environment that you're in. That being said, we do provide some recommended rules that are probably for most environments about a 90% configuration solution, I would say, with just a little bit of modification needed based on the exact needs of the environment that you're protecting. All right. So the next part that I want to show you is the exploit prevention and virtual patching. Now, this is going to look a lot like what we just saw with anti-tampering. We're going to be using a lockdown rule here as well. And I'm going to go ahead and let this play until we at least get to that point. And what we're going to see is that one of the hosts that I'm protecting here is actually vulnerable to one of the virtual machine escape vulnerabilities that we talked about, specifically the one that was disclosed in 2025. The one that was disclosed in 2025 affected a bunch of ESX hosts, especially in the 8.0 versions, is a lot of where its impact was really felt. And so one of the hosts that I've got here in this environment is a vulnerable host. before we take a look at it, we'll just look at this VMX rule. Now, this is going to look really similar to the last one, where we were looking at hostd executing a specific set of commands. But what you'll notice is this is also a program execution rule, but the source process this time is VMX, right? One of the processes that handles a ton of the virtualization that's happening on ESXi. And it's looking for it to attempt to spawn a process that matches the second regular expression. So things like sh, busybox, ash, Python, wget, all sorts of things. And honestly, within the busybox process specifically, there's a lot of other processes that are contained within that just because of the nature of busybox. So this gives us a pretty good idea of a lot of the utilities that we might see an attacker using as a follow-on to doing a virtual machine escape and how we can protect against it. Oops. It looks like the video restarted on me when I hit play there, but we'll get right back there. Take a look at that. Okay, so we got our VMX process as the source, and then we've got a bunch of processes that we know an attacker might be interested in. And what you're looking at right now is a guest operating system. So we're not on the ESX host. We are on one of the virtual machines. It's just a little Linux Ubuntu virtual machine. And unfortunately, I have access to this one. I have an administrator level access to this particular machine. And I've got my script for CVE 2025-22224 loaded on there. And we're going to go ahead and run it and see what happens. It takes just a minute. This is a memory corruption attack. But if we get a successful escape, then it should drop us into a shell on the ESX host, which it said that it was successful, but it didn't look like it actually dropped us into that shell. And what you'll see here is that we got an alert for VMX. And if we take a look at the whole chain that's associated with it, you'll see that it's coming through the VMX process. And if you look at that, and this was what my script intended to do. It intends to build an outbound network connection to try and reach out to a shell outside of the host. So this gives me access as an attacker to that ESXi host if I'm able to successfully do that virtual machine escape. And that is what ZeroLock was able to detect on. It notices that VMX is trying to do this nasty shell command and make that outbound connection, which is not typically something that we should see VMX doing. That's why we call this a virtual patch. It addresses a vulnerability that exists within ESX that maybe there's not a real patch available for. And although it doesn't solve the problem at the software level, it does solve the problem at the behavioral level. It prevents that exploit from being utilized for malicious intent. So even though I had a vulnerable host and I had a valid exploit, I was not able to do what I wanted to do as an attacker at the end of the day because ZeroLock was able to identify that behavior and stop it. Okay, so now we get into some of the really fun stuff. I'll go back to this just briefly. This is kind of the protect section of what we talk about. So we've seen a lot of things that are preempting. They're preempting the behaviors, the nasty things that an attacker might want to do. They're stopping us from using an SSH session that we shouldn't be using, stopping us from removing ZeroLock. They're preempting a lot of follow-on impacts that might happen over the course of an incident. But now what we're going to get into is, let's say somehow someone makes it around every single one of those preemptive protections, right? So they are able to either disable them or some sneaky way to circumnavigate them, which is unlikely, but let's just say that it had happened. What we're going to get into now is a living off the land ransomware attack. So we're not going to be using any, malware. There's not going to be some kind of binary that we're going to bring in. We're going to use only tools that exist natively on the ESX host itself. And you can, if you're familiar with some of the tools that are there, you can kind of look at the command that you see on screen here and start to break that down. I'll help you out with it a little bit though. What we're looking at is a one-line script. So there's a series of commands here that are all being pasted one line into the terminal that are going to act like a ransomware attack. It is a ransomware attack, right? It's just not using some foreign binary to do it. So the first thing that it does, if you remember, we had our Frodo, Gandalf, and Gimli virtual machines on this host. It's going to be targeting Gandalf specifically. So it's going to use grep to search for all the files associated with Gandalf. It's then going to pipe that into xargs, which is going to, spawn another shell underneath that. And then I apologize, this gets a little bit cut off, but this is an OpenSSL command right here. OpenSSL is one of the underpinnings of, modern open source cryptography. It exists by default on most Linux hosts, on all ESX hosts. And this is it's going to use AES 256-bit encryption to encrypt files that we pass it from that Gandalf directory. So it's doing just what ransomware does, right? It looks at a directory or a series of directories, it finds all the files inside of them, and then it passes them to an encryption routine. It encrypts the files. It maybe puts a spooky file extension on the end of it, which in this case, you can see this nuclear radiation symbol here. That's what's being put at the end of it. So I'm going to go ahead and let this run. Now, you saw how quick that was. I hit enter, the cursor went down, and then within a few seconds, it gives us a warning about deprecated key derivation and everything. But then within a few seconds, our connection gets closed. Okay, so this is important to kind of see how quickly ZeroLock was able to respond to this attack. So we ran our ransomware attack. And if we click on the alert here, it says that there's 5 files affected. Now, 3 of these are just the shell history and the config and schema files that get modified when we do normal SSH login. So these 3 are normal. However, these 2 down here are not necessarily normal and are not necessarily things that we want to see get modified on our host. The first one is the Gandalf VMDK file, and you can see that ZeroLock is listing it as modified. The reason I'm calling this out is because it's important to know the depth to which ZeroLock is able to do this monitoring. So as it's watching all the processes go through that we saw just a moment ago when I started to run this, it's also tracking all the file changes that they make, all the files that they request to modify, and that they actually do modify. So in this case, it knows, hey, the VMDK file was modified. And then there was a new one created. And you can see, I know it's a little bit small, but there's a little nuclear radiation symbol, spooky file extension there at the end. So that one was created, just a copy of Gandalf that had that. Now, I'm gonna give you a little bit of a spoiler. The modification of the VMDK file is actually its removal. It's modifying the file by deleting it. And this new file is being created as the encrypted version that the ransomware is going to leave behind. So I'm going to go ahead and let this continue to roll through here. So we see those files that got modified. And if we come over here to processes, this is nice. Oh, whoops. We got to reset the video again there. I'm going to go to the processes. Okay, so we see this. This is great to kind of see it in the tree graphical view. You can see the OpenSSL command that gets called here with the VMDK and the nuclear radiation symbol. You can see all of those commands that were associated with my living off the land ransomware attack. ZeroLock gives us access to all of it. Now, if I come over here before anything else happens and I try and turn on this Gandalf virtual machine, we get this error. And this is a pretty bad day for us as, an ESX administrator because we can't turn on our Gandalf virtual machine. The VMDK file is missing, right? Which makes sense. We know that the original VMDK file was deleted and that there's a new one that has that symbol on the end of it. And it's not the file that ESX is looking for. So this all makes sense. And it's a pretty bad day because what we're going to do if we drill down on this as an administrator is we're going to realize that we've been hit by a ransomware attack and that Gandalf has been encrypted and is no longer in a usable state. So this is a pretty bad day for the administrator initially. But what I'm going to do is I'm going to hit this big blue remediate alert button. Now, when that happens, you'll notice, and I know this happened really quickly, but over here on the right-hand side of the screen with status, everything is now listed as either removed or restored. And we're seeing that this alert is being listed as remediated. So when we talk about remediation when it comes to ZeroLock, really what we mean is that all of the files that were modified over the course of that malicious behavior have been reverted to the state they were in before modification. Now, oftentimes we get questions on how exactly we do this. And while this goes, I'm going to let the video run. What we're going to see though here is that now if we come back to Gandalf, we're able to power it on. So we saved the virtual machine because ZeroLock was able to revert it to the state that it was in before the attack happened. You can see it's just a little Alpine Linux VM that's sitting here waiting at login, right? So it's not doing anything fancy, but it's a legitimate virtual machine that we couldn't power on before because it had been encrypted. But after ZeroLock goes through the remediation process, we were able to save it. This is a pretty powerful capability that we do. This is what we talk about being that automated file rollback. I did it manually for the sake of the demo here where I pushed the big blue button, but we recommend in most production environments that this is something that you set to auto remediate so that a human doesn't have to push the button. ZeroLock, just when it sees a ransomware attack, it stops it, it kills it, and it undoes any file changes that might have been made. That's the way to reduce downtime and to really fully mitigate the attack to the most effective way possible. And it has the exact same result as what you have seen here. Okay, as kind of a bonus here, I'm going to show you blocking the creation of rogue VMs. This is a really interesting technique that has been used a little bit by both researchers and by legitimate, more sophisticated threat actors. Usually, these are ones that are not ransomware actors. This is more espionage and intel and kind of disclosure groups where they go and they steal customer data and then they intend to like sell that data or something like that. What they sometimes do is they start a rogue virtual machine in the environment so that they have long-term access, right? So this is another way of giving themselves a backdoor and kind of a staging point within a virtualized environment. And it's something that we see people do by calling the VMX process directly. So if they already have access to the hypervisor, then they can start their own virtual machine. They can bring in their own virtual machine and start it, and then they suddenly have, a toehold in this environment if they don't already have one in another way. So what I'm going to do, this is a legitimate way to establish a rogue virtual machine is by calling that VMX process in that way. And as you may have noticed, it actually got stopped. We weren't able to really start it, and ZeroLock was configured to be able to block rogue VM creation. And you can see all of the data that it's reporting about exactly what the attacker attempted to do here in that alert now. So this is just kind of a fun gee whiz one. Doesn't relate directly to our layered defense onion that I showed you all earlier, but still a really, really powerful capability. So this has been, I think, a pretty good, decent overview of exactly how we're doing protection. And it's a little bit different than how VCF is doing protection. VCF is doing a lot of really, really good things. Again, mostly at the network level, the compliance level, and then making patching a lot easier than it used to be, which does help address some of the vulnerabilities that we talked about today, but only when those patches are made available. The way that ZeroLock helps with a lot of these problems is by doing things in real time and providing much deeper protection at the host level. So assuming the worst, when your attacker has gotten through the network defenses, they've spoofed one of your administrators, they have access to all the things they want to have access to. ZeroLock doesn't give up at that point. It continues to be able to protect, and it's not out of scope for ZeroLock at that point. In fact, that's really when ZeroLock, I think, shines the most. If you have interest in any of this, or if you want to learn more, some really good resources that you can begin with and even share out with other members of your team who weren't able to make it here today are at these QR codes here. So you can see some of our one-sheeters around how we interplay with VCF and why it's kind of a better together situation, and you really should have both VCF and ZeroLock enabled to buy down risk as much as you possibly can in your virtualized environment. We also, this is one I really like. Over on the right-hand side, we have an assessment that we offer for free to people that you can, it's a self-assessment where you can go through and you can ask yourself the right questions to figure out how secure and how much risk you're incurring in your virtualized environment today. So that was one I definitely highly recommend, even if you're otherwise not interested in anything we've talked about here today. I think that can be a really good tool just for understanding where some of the risk might be in your environment right now. And then, yeah, there's a VMUG exclusive there that you can do to be eligible for some free ZeroLock licenses, and there's some more details within that. I hope that a lot of the things we've talked about today have really demonstrated the value and power of ZeroLock for you all. And now we will get into questions. In a second, I'm gonna go back to the QR code slide in case there's folks who wanted to get at it that didn't get a chance to. But now I'll turn it over for Q&A. I think we got Megan here to help facilitate, and I appreciate y'all's attention.
Yeah. Hey, Nathan, thank you so much for that wonderful session. And everybody, thank you so much for joining us. I'm Megan Howard. I'm the VP of Marketing at Vali Cyber. So Nathan, one of the things that I was curious, we're talking a lot about VCF and ZeroLock
Yeah.
and the different protections that they offer and how they work well together and really create a holistic and solidified surface. One of the things that I've been hearing more about is for instance, companies considering having a few different hypervisors, kinds of hypervisors, having a multi-flavor environment depending on what they've got going on. This could
Yeah.
also involve different acquisitions of different businesses and the kind of equipment that comes with them. I was curious about, your thoughts on that when you've got a multi-system and you have VCF that's able to observe some network, but then the power of having ZeroLock kind of across these multiple hypervisors.
Yeah, I think it's a really good scenario, and it is due to recent circumstances with pricing and things like that. It's become one that I think a lot of organizations are considering more is, hey, do we want to have an only ESX environment, or do we want to move to other solutions as well, maybe to like augment what we have? Yeah, unfortunately, VCF only works within the VMware environment, right? So if you have total lock-in and you're an ESXi only, again, it's great. It does really good job of what it does. ZeroLock works across all of those. So all the protections that we talked about today that ZeroLock does to help out with VCF, um, those are all going to be applicable across the wide range of hypervisors. So if you're running Nutanix or Citrix or Proxmox or what have you in your environment, you can have a lot of the same protections that you've got on ESXi through ZeroLock on those as well. That won't necessarily be the case for VCF, and rightly so, right? We wouldn't expect that VCF would necessarily work on those. But yeah, I think that there's a lot of value to be considered here, especially if you're considering moving off of ESXi, or you are broadening it, or due to acquisitions there's other environments that you have to support. I think that VCF, there's not a lot that it can do to play in those spaces, but ZeroLock was built for those spaces. So yeah, I think it's a really good question. I think that's really the way I'd look at it.
Got it. And then just as a reminder for everybody that's here with us today, if you do have any questions, please feel free to put them in the chat and we'll make sure that we answer them. Um, Nathan, I was curious when you were talking about some of the network protections. I think in particular, the advanced now the name is skipping my head. What is the advanced oh heavens to Betsy.
For VCF itself.
Yeah, for VCF itself.
Oh, is it the advanced compliance stuff? Is
That's
that
what
what
I'm
you're talking
thinking
about?
of.
Yeah.
Yeah, the
Yep.
advanced compliance stuff. So, in considering that, I was curious about, you said that it's a little more reactive, I guess, in that, it's checking to make sure that you are compliant, but it's
Right.
not necessarily doing some more of that like active, preemptive
Yeah.
search. And I think kind of when we start thinking about, you know, AI starting to enter the threat landscape and everything like that, and we talk about,
Oh yeah.
vulnerability discovery becoming so much more of a central thing. Um, what would your thoughts be on, something like advanced cyber compliance and how it can be useful, but then, in this particular scenario, what are your best options to make sure that if vulnerabilities are getting discovered faster and faster and faster, you are
Yeah.
able to still maintain this cyber compliance?
Yeah, that one is really tough. That's a problem I think we've heard echoed from tons of organizations right now is that vulnerabilities, and in fact, for anyone listening, like I don't know if you've seen some of the stuff with the Linux Foundation talking about the rate
Mm.
at which vulnerabilities are being discovered and disclosed to them. They're like, look, we just can't address all of these. And that's across multiple organizations too, not just them. I think that's a really big sentiment right now. AI has proved to be pretty good at the technical work of discovering vulnerabilities. I think it's actually a task that it's uniquely well suited to. Um, it's hard. It's very, very hard for a lot of these organizations to keep up. You talk about keeping up with compliance. The part of the problem is that compliance can't keep up with the vulnerabilities, right? Compliance frameworks have to be written by experts and by researchers who understand what, it's a confluence of legal and technical and like administrative and business needs that go into compliance frameworks and to ensuring that you even know what compliance means in the first place, right? And then there's the task of making sure that your machines stay compliant, which is really what I think the ACC capability is really getting after. So I guess I don't know how else to answer this question other than that. I don't think compliance frameworks and keeping track of compliance is going to be the thing that saves us from these increased vulnerabilities. I think it's going to be behavioral and preemptive security, right? I think that's really what's going to do it because we have to have solutions that are broad enough and powerful enough to address the unknown vulnerabilities, right? The ones where, look, we know what an attacker wants and we know what they're going to try and do. We don't know exactly how they're going to get here in the first place because we've never seen it before. They're going to have some new novel exploit that AI found for them that no one's ever seen before. But at the end of the day, they're going to be using the same pathways and they're going to be they're going after the same data. And I think that's what ZeroLock does. I think that's what any other good preemptive security solution does. And it's what's going to be required for a lot of these new vulnerabilities. I think at the end of the day, I think the compliance conversation is a really good one to be having, and I think tools like this will help people keep up. But I'm not sure that the compliance frameworks themselves will keep up. I think that's really kind of going to be the bigger problem.
Yeah, no, it's interesting because I do know, there's certain industries, for instance, aviation pops immediately to mind,
Sure.
where they have really strict requirements around
Yeah.
how fast they have to patch, when a vulnerability gets released. And
Sure.
my heart is just kind of going out to them
Yeah.
and like
Yep.
the reality some of these industries are starting to face because it's just it's starting to feel a little Sisyphusian, for lack of a
Sure.
better, it's like you're just I just don't know how folks are going to get ahead of this, but I think you're right.
Yeah.
That shift in mindset set to being preemptive and, looking more holistically, what are the behavioral changes we can go after to help
Yes.
ensure that, whether it's exploit 1A or exploit 1B, they're still following the similar behavior paths, and so we can make sure we're defended against that behavior path.
It's really tricky. It's hard because these vulnerabilities are all similar, but just slightly different. And they each require a unique patch to be able to do it. And yeah, in industries where they have those strict requirements, it's going to be really, really hard to do anything about it. What I would hope for a lot of those industries is that they have, verbiage in the compliance frameworks that says things like mitigating the vulnerability rather than, outright. Because if a patch isn't available, a patch isn't available. You know what I mean? And that's the other half of this is like it, the patch availability makes a big difference in when someone can even do anything about it. And a lot of times compliance frameworks are great and we should be adhering to them as a minimum, but the truth is they may not make you secure at the end of the day. There might be some things where in the instance of these, VMX vulnerabilities, there was at least 2 months for each of them where there was probably a vulnerability or an exploit that existed in the wild. There was definitely a vulnerability, and there was no patch, right? So even if an industry has, you got a patch within 2 hours when it's available, if there's 2 months where there's no patch available, then they're still kind of out of luck for the interim time. So yeah, well, we could talk, that could be a whole nother presentation. We could do probably a series of presentations on this, but
Yeah. Well,
yeah,
thank
good
you so
question.
much for your time, Nathan.
Yep.
And thank you so much, everybody else. We are at time, so I will start to wrap this up. Um, Hey, on everybody's mind is VMware Explore. Nathan's gonna be there if you want to geek out with him and talk preemptive security. Let us know. Shoot us an email at valicyber.com/contact. You can submit a form, and we'd love to find some time to connect with you while we're there. Thank you so much to VMUG for hosting us, and most of all, thank you so much to everyone who chose to join us today. We will have another webinar happening. Date is TBD, but I'm kind of excited about it. You guys may have heard about the unfortunate attack on Fairlife that happened recently by Anubis, the threat group. And so we're going to be diving deeper into that path and better understanding what happened there. So date TBD on that, but really, really, I think it's going to be a very interesting session. With that, I will hand things back over to Tristan. Tristan, thank you so much.
Thank you guys. And again, as Megan said, thank you everyone for joining. I'll keep it quick. Once I end the webinar, you all will be prompted to fill out a survey. Please take just a few minutes to fill it out. It'll help us bring you fresh and relevant content in all future webinars. And the session was recorded. So look forward to that in your email and also check it out on the VMUG YouTube channel. But everyone else, enjoy the rest of your day and thanks again for joining.
Bye,
Take care.
everyone.